Hello everyone. Today I will give you a presentation about the CO sensor for the residential and commercial CO alarm. Because all over the world, the CO alarm has a widely application, no matter in China or outside China, especially in US and some European countries. It is illegal if your home is not equipped with the CO alarm. So it has a widely application. For such a application, such a wide application field, which kind of sensor is more suitable for this application? I will give you some introduction of this. This is our overseas exhibition just last month, and this is some site. My colleague, very beautiful and very happy there. And for this one, our ProSense. Now we are the committee member of UL 2075 and UL 2034 and UL 2201. We are the TC member in these three committees, in this three standard committee, because we just specialized in the fuel cell sensor for many years. And the UL standard, the standard committee, they need some company that are specialized in a special technology. So we are the committee member in this 3TC. And the CO sensor, it has a widely application from the residential and commercial alarm to the portable generator to the detector for BESS and the industry application, and also for the portable detectors. All of this, they need the CO sensor. But for all of these applications, is only one sensor can be applied to all of these applications? The answer is no, because for different application, it needs a different principle or the different parameters of the sensor. Like for the residential alarm, the sensor must have a low interference from the VOC gas and should have high stability at a very low concentration. And for the portable generator, the sensor should have the ability to anti-poisoned by the gasoline. And for the detectors of BESS, it should have a very long life and can stand the silicon poison, and it should have a wide temperature range. So for different application, vertical application, different requirement, and it will have a different pinpoint. For the BESS, the problem is silicon poison, and for the portable generator, it's the gasoline poison. And there are some other pinpoint like the sensitivity drift at higher temperature, and it cannot stand salt and the other problems. So we need to do a thorough research about the vertical application to determine which sensor is more suitable for this application. For an alarm or a detector, the sensor is the heart, because the sensor determines the performance. The sensor determines the performance. The sensor gives the signal. The package or the PCBA, they just collect the signal and transfer the signal to the ppm concentration. By this, it cannot change the basic performance of the sensor. If you do not choose a good sensor, there may be some fire. It will fail at the site for the big fire, and maybe there are some reback of your products on site. And also there may be cause some legal problems, because there is a company in China is carbon monoxide alarm failed to work and caused several people died. And the boss of the company is put into prison. So the CO sensor is related with safety, with life. So we must pay more attention to this to choose a suitable one. Now let's say the technology that can detect for the CO sensor. There are the fuel cell, the electrochemical, NDIR, and MOX. That are these four principles. For the sensor applied in the residential and commercial application alarm, most of these or almost all of these sensors are the fuel cell technology. Why? Because this one, it has low noise, high signal to noise ratio, and long life, and zero power consumption. For this application, the alarm is usually powered by battery. If it is powered with a lithium battery, it requires that the alarm can work for more than 10 years without changing this battery. So for this, the sensor must has the power consumption as low as possible. This one, it has zero power consumption. So for the residential and the commercial alarm field, almost all the sensors are this one. It has the working and the counter electrode to finish the detection, and the current generated just be detected by the external circuit. By this, we can detect the concentration accurately. That is this principle. There are two types of this fuel cell carbon monoxide sensor. The one is coin type. The other is the battery type. All the battery type, there is a long tank. This one is first be launched. Why this one is first be launched? Because in this tank, it contains water. Why it contains water? Because carbon monoxide, it can only be detected with this technology together with water. If there is no water, the sensor cannot work. So in this tank, it is full of water. The water will be consumed time by time by the reaction. So the lifetime of this sensor is determined by the water in this tank. So this is this one. And for the coin type, since the water is so important, why it comes the coin type? Because there's no water inside. How can the sensor survive? The manufacturer also claimed that the lifetime is more than 10 years. Why? That one with water, this one without. How can this survive? Let's say this part. This is the reaction of the carbon monoxide. Here, when carbon monoxide comes, there is a water together from the air with it. And they are together turned to carbon dioxide and proton. Proton will come through the electrolyte and reach the counter electrode to react with oxygen. By this, one water is generated at the counter electrode, and one molecule of water consumed at the working electrode, one is generated at the counter electrode. If we can make this molecule from the counter electrode to go back automatically to the working electrode to participate in the reaction, this one can work together, so water is not needed. There are so many coin-type CO sensor. It seems that everyone have solved the problem of the water recycle problem. So is that the reality? This is the reaction equation. From this, we can see clearly that this water is consumed at the working electrode, and here is generated a water molecule. If it can go back to here, so there's no need for the external water to be contained in this one. From this, we can say that these are the tests. Two of the coin-type CO sensor in the market tested them at high temperature and low humidity. High temperature, at high temperature, if you do not to give the humidity extrally, the humidity is usually very low. At 70 centigrade, the humidity is usually lower than 10%. Both of these are below 10%. Both of these two sensors, their sensitivity drift significantly. So for the answer of the question is all the manufacturers solve the problem of water recycle? Do all of the manufacturers solve this problem? The answer is no. If everyone solve this problem, these two sensors, their sensitivity will not drift so seriously in the low humidity. And in this pinpoint for this application, why do we want to use a sensor without water? Because in this tank, here the water comes automatically from the context part. This one happens on site, usually happens. So for this application, if the water is go out automatically, we call it water leakage. When there is water leakage, the sensor will be short connected and it will give false alarm. And on the other point, we all know that the things with time going by, the things to become smaller and smaller. For the alarm, it is the same. In the past, the alarm is very big, and nowadays we want to use a small alarm. For this sensor with the water tank, the size is very big, especially if we want to use the sensor together with the film sensor. The size of the alarm will be very big, so we want to use a small one. That is the reason why we wanted to make a sensor without the tank. For a sensor, I introduced the background and how we can to charge the stability of the sensor, or the stability of a CO sensor determines by water factors. The first one is the principle. Principle, I think it is the basis, because if you want to use a sensor with long life, more than 10 years, if you use electrochemical sensor or semiconductive sensor, it cannot meet your requirement at the basis, because for that two principle, the lifetime is short in theory, less than 5 years. Electrochemical is usually 2 to 3 years. So if you choose a not suitable principle, everything is wrong. And then it is the stability of the catalyst and of the electrolyte. And also the production line is very important too, because this sensor is usually be sold very, very many every year. If you assemble the sensor by hand, the consistency cannot be good. So they are usually be assembled automatically by robot. So the production line is very important together with the stability. And now, what are the components in the CO sensor? From this, it can give us some idea. There is a package. This is the inner part. We call it MEA, or the electrode membrane, the electrolyte, the working and the counter electrode. This is the heart. All the electrochemical, all the chemical reaction happens at the MEA, and the other part is the package for the sensor, and then the water in the tank. The package, it cannot change. There will be not a problem with this package. So only 3 components with the sensor: the electrode, all the catalyst, the electrolyte, and also water. These are the 3 ones. If the sensor fails on site, that must be one of these 3 failed. Now let's check one by one. For the catalyst, why the catalyst can fail? Because the catalyst has the risk of be poisoned by the VOC gases in the environment, together with the CO. Like at home, if we use film, if we use air freshener, this one they usually have big molecular. It cannot be totally decomposed on the catalyst, and just like this, it will leave someone on the catalyst. So the catalyst, the totally surface area becomes smaller and smaller, and the sensor sensitivity will drift. And for the electrolyte, If you cannot solve the problem of the water recycle, it will also lose the sensitivity. So these are the two reasons. For the poison of silicon or other big molecule, we can see this video. This is the catalyst. When there are silicon or other big molecule come here, they just stick on the catalyst. And the catalyst cannot decompose them and cannot get them away. They just stay at the catalyst. And when carbon monoxide comes, there's no enough catalyst for the reaction. So the sensor will get poisoned, just like this shows. The current becomes smaller and smaller. So that's of the poison of the catalyst. And for the dry of the electrode, if there's no water inside, there's also no water from the outside. There's no water in the water tank, and the humidity is very low. There's no water to compensate for the reaction, and the carbon monoxide comes here. There's no enough molecule of water to react together with this reaction, so the sensitivity drift. That's the reason why water is important, and the recycle of the water generated at the counter electrode is so important. That's why, because without water, the chemical reaction cannot happen. So if we know the background and we know what are the key factors of the sensor, what are the key performance of the sensor, the sensitivity, the accuracy, the consistency, and the stability. All the CO sensor in the market, there are no problem with the sensitivity because all the catalysts are platinum. If we use platinum as a catalyst, the sensor have enough sensitivity. The accuracy determines not only by the catalyst, but also by the temperature drift of the offset and also of the sensitivity. So the accuracy is important, and the consistency and the stability is also very important. So for a sensor, if you get a sensor, you just check these 3 points. This one is the test data of the sensor to 5 ppm CO, and these are the sensitivity drift after the storage at 60 centigrade. These are 2 sensors. The upper one, it is very stable, and the lower one, the sensitivity drift greatly. If you use this one, how can you say that your alarm or your detector has a lifetime more than 10 years? It's a joke. And this one, it is the selectivity test of the sensor. And this one is the sensitivity drift at room temperature. There are some sensors, their sensitivity drift seriously even at room temperature. So this one determines the stability of the sensor. If you test the stability of the sensor, please pay attention. Prolong your test period at least 3 months to check whether the sensor has its stability, especially raised temperature. Because when we raise the temperature, we are doing the acceleration test. If we say a sensor, it has 10 years. We cannot test it at room temperature for more than 10 years. But if we raise the temperature, the chemical reaction is speed up, and it can give us some index of the lifetime. So please make sure that you use the right method to evaluate the sensor. And just like I just said, the accuracy, it's related with the temperature drift, the temperature drift of the offset. These are the sensors of 5 manufacturers. The last 60, they are from 1 manufacturer, 2 model, and the former 4, they are from 4 manufacturers. We can see that This is the sensitivity drift for the first 31. The sensitivity drift from lower than 100% to more than 150. For this sensor, the sensitivity drift is significantly. We must do the temperature compensation, but it is impossible for us to do the compensation sensor by sensor, because the technique or the cost cannot support us to do this. We usually use one compensation equation for all the compensation by this. If the range is small, you can do a better compensation. For the first manufacturer, the temperature drift sensitivity temperature drift range is more than 60%. That means even we use the middle part, the sensor has a minus and minus plus 30% error, just arrives from the temperature compensation. If it is together with the sensor, the error of the sensor itself, it cannot give us an accurate result. But for this last two, the range is very small, so the compensation will have a very good point. And this is the drift of the offset. For the offset, when we use a sensor, the current is detected by the PCBA. If the offset of the sensor, some of them are minus, some of them are positive, we cannot do a compensation because the PCBA, it cannot charge now whether it is the offset or there is carbon monoxide. So we usually to adjust the offset to positive. When the offset is low, it can give us accurate compensation. If this one is very big, the error caused by this one, it will be very big, because for the sensitivity temperature drift, we can use an equation to do the compensation. But for the offset, how can we do the compensation? We can see that all these nearly 200 sensors, the offset, they are not in a narrow range. We do not know how to do the compensation. So for the offset temperature compensation, most manufacturers, they didn't do. If you do not do the compensation, the offset drift must be very low. Only with this value is very low, you can get accurate detection. And also the repeatability of the sensor is very important. And by this, please check the repeatability of your sensor. This one, it has a good repeatability, and this one, the two sensors, they have different response when we do the repeatability test. And this one, it is the polarization of the sensor. When there is carbon monoxide for a very long time, more than 12 hours, the output, it cannot follow with the real concentration. So all of this will affect the accuracy of the sensor. Now, for a sensor, if you want to evaluate the sensor quickly, just test the consistency and the stability. These two are vital for a sensor that can be used in batch. For a sensor, there are three types. One is that it has no UL recognition, and the second part is that the sensor has UL certification, but it is not to be used for the real application. That means there's no alarm or no detector use the UL certified sensor to get the alarm certificate of UL, because the sensor and the certificate test for a gas sensor and for a detector, the content, the items is quite different. For a sensor to get the UL certificate, we only test the 1 year stability, and all the other performance you will think that it should be evaluated together with the detector. So even if the sensor itself has a UL certificate, it doesn't mean that the detector can pass the UL certificate, UL pass the test, because there are some tests like the humidity test and the temperature test. Maybe the sensor cannot pass the test. That's the inner part. But on the top of the sensors, there are the sensor that it has the UL certificate, and there are alarm or detector that use the sensor to get the certificate of the detector. So that's the clarification of the CO sensor. Now, ProSense, we launch our CO sensor, all of them are without water. Why? Because we found a phenomenon by chance that with the water become smaller and smaller, the air content in the tank becomes more and more. We all know that if there is the same temperature change for the water or the liquid, the volume enlarge is much smaller than that of the air. So when the water becomes fewer and fewer and the air content becomes more and more, the inner pressure becomes larger and larger, just because the expansion coefficient of liquid and gas, they are quite different. So by this, this difference will cause the offset drift at different temperature. It cannot be a stable value. If the water is full of the tank, it has a offset at high temperature. And if that is low, the water becomes smaller and smaller. The offset will be changed to another value. So by this, we decided that we will not develop sensors with water anymore. We just focus on the coin type. And these are the CO sensor family of ProSense. We have the UL recognized the battery type and also the kin type, and also this one for small size application. All of them have more than 10 years lifetime and minus 40 to 70% centigrade temperature range. And all of this has the anti-poison and anti-interference ability. And they are widely used for the BESS portable generator and also for the residential and commercial alarm. These are the sensors from ProSense. Why we can focus our CO family totally on the route that without water? Because we solve the problem of the water recycle. Between our catalyst and the electrolyte, there is a proton-bonded layer. By this, it can absorb water automatically to absorb the water generated at the counter electrode automatically to send it back to the working electrode. By this, our sensor can survive, can keep its performance at low humidity without water compensation. These are the tests of the sensor at very low humidity and at high temperature. It's very stable. And also how we solve the problem of the poison of the catalyst. Because we all know that the sensor uses the platinum particle. When you use different method to get the particle of the platinum, the crystal of the platinum is quite different. If we change the crystal of the nanoparticle, make it very sharp, when the big molecule come here, it cannot stick to the catalyst molecule. We can solve the problem. And also we use the composite catalyst that has the better performance of the anti-poison ability. So by this, we solve the problem. And these are the tests of 4 sensors through the common widely used materials during the PCBA production. We can see that sensor 1, it has a good anti-poison ability, and both of these 3, they are seriously poisoned and can never be recovered. The sensor cannot recover by itself. The sensor failed. And these are the tests of the sensor with silicon to seal with the silicon for a very long time, more than 1 month. We can see sensor 2, it has the problem of silicon poison, and the other 2 sensors, they didn't be affected by the silicon. ProSense, we have these 4 sensors. You will recognize the CO sensor and the hydrogen sensor, and the hydrogen sulfide sensor for the solid-state lithium battery, and also our widely used formaldehyde sensor, the first choice of air purifier. And also, it has a lifetime of more than 6 years. It has more than 70% market share. And we usually keen on the sensors, so we can make the sensor have better performance. Now, if you want to make a detector or make an alarm, you know the knowledge about the sensor. We do a product. Our target is to make money, to get profit. The lower the cost, the better the quality, the lower the cost, and the more profit. So we must pay attention to the quality of the sensor or the quality of all the components in your alarm or detector. When for the residential and commercial application, the sensor, it usually meets with the interference gases like alcohol, sanitizer, fume, and a lot of this one will give interference and also a poisoning through the catalyst. That is the risk of the sensor. This one is the test of these 3 sensors through the air freshener. This is a very commonly used air freshener in China. But for this one, it gave a false alarm. When you use air freshener, it says that carbon monoxide is come. Carbon monoxide comes. Run, run, run. So it gives a false alarm. But this too, it didn't give false alarm. But even if it didn't give false alarm, does the sensor did a good work? Maybe not. Let's say this. After this test, before and after this test, we checked the sensitivity drift. We found that this part, the sensitivity drift seriously. That means even if it will not give false alarm, it will give missed alarm because the sensitivity drift significantly. So we need to choose a sensor has low interference from the other gases and also has a good anti-poisoning ability to ensure this. And when the sensor or the alarm is used in kitchen, please pay attention to the fume and the seasonings affect interference to your detection. And also when you make the alarm, please make sure that on your package there is the gas pass. That means the gas comes in from one side and go out from the other side. By this, the sensor has a good response time. And pay attention to the ammonia effect. Ammonia is commonly with the foam and with the plastic parts. The ammonia will react with the acid part in the sensor, which will cause the sensor damaged, maybe died permanently. It cannot recover. These are the results of this reaction. For this sensor, it loses almost all the detection function. So please pay attention to the effect of ammonia. And when you design the PCBA, please make sure that there is the anti-polarization part. Why the anti-polarization part, that is this part, why it is so important? Because when the sensor is connected into the PCBA, if there is no anti-polarization part, when the alarm is not power on, the working and the counter electrode, they are disconnected. The sensor, they are working all the time, no matter whether it is powered up. The electron will be collected, will be accumulated at the counter electrode. When you power up, the alarm will give a very high concentration. It will give you a false alarm. Maybe it takes 1 or 2 hours for the offset to settle down. If you have the anti-polarization design on your PCBA, there's no need. Once you power down, it can give you an accurate detection. And please make sure that you make the water, the temperature compensation through the offset and through the sensitivity. And also make sure to check the humidity effect of the sensor you choose. Only when the sensor has a little affected by the humidity, the sensor can give an accurate result. And also please make sure that you make the pressure compensation. By this, we can ensure the performance of the sensor. And when you get the sensor, you can calibrate your alarm by 2 methods. One is with the information in the barcode. There is a barcode on the sensor. It stores the information, the calibration information of the sensor. You can use this information to calibrate your alarm or your detector, or you can use the carbon monoxide gas to calibrate the total detector. We strongly recommend this way because the accuracy determines by 3 parts: the package, the consistency of the package. There is error of all the components, the parts. Just like we say the size of the pore is 1 millimeter. It has an error. If the error of the 2 parts, they have minus and positive error, it will give different result. And also for the PCBA, it also has the temperature effect on the electronic components. It also needs compensation. So if we calibrate with the carbon monoxide gas to calibrate the detector, you calibrated the difference of these 3 parts. But if you calibrate with the barcode information, only the difference among sensors is calibrated. So please make sure that you are better to use this way to calibrate the detector. And also please pay attention to the offset of the sensor. The offset, when the temperature is higher, the offset there usually becomes bigger and bigger. Please make sure to check your sensor's offset drift together with temperature. What is offset? Offset means the output when there are no target gas. If there is no target gas, there are oxygen at the working and counter electrode and other VOC gas. They will contribute to the offset of the sensor. The offset of the sensor, please check, make sure that it has a low value at higher temperature. By this, can the detection be accurate? And if the sensor, if you buy a lot of sensor and cannot use them right away, please make sure that you store the sensor at low temperature. Because from this equation, we can see that if the temperature is low, the chemical reaction is slowed down. It slowed down means the sensor, we can prolong the lifetime of the sensor. And when the sensor is in storage, please make sure that you also use the anti-polarization mirror just to connect the working and the counter electrode by this. When you take off this part and connect it into your PCBA, the sensor can be get into work right away. If you do not use this method to do the anti-polarization, when you connect the sensor into your PCBA, it will need you 1 or 2 hours for the sensor to settle down. So that's very important. That's the information about this presentation, and these are our contacts. If you are interested with our sensor or our company, please contact with us. Thank you.